In this practice, we did the impact test, but in order to understand what we did, we have to first know what impact resistance means. Impact resistance is the ability of a material to withstand a high force over a short period of time. This is important because a high force over a short period of time has a greater effect than a small force over a long period of time. The impact is also proportionate to the velocity of the colliding materials. For example, in the test we made, the weight goes from this height to this height in a very high speed, and it hits the material with a high force.
The ISO impact strength test is like we did in class. For example, this test consists of like a pendulum machine. We wrap the pendulum to a specific heat when the potential energy is accumulated totally, and then we release the weight hitting the specimen, and then this pointer will let us know where the specifications of the material.
Another test we can make is the Sharpe impact test. This is a lot like this one, but the only difference is that instead of having 2 points of equilibrium, it only has one. It also helps us measure the ductile to brittle temperature and the properties of the material. For example, the notch toughness, which is the energy absorbed by the material when a fracture is caused.
By definition, a fracture is divided a solid material into two or more pieces. And in mechanics, we have the brittle fracture and the ductile fracture. The brittle one is when you it's like a fracture with no apparent plastic deformation, and it's like the piece I have here. It's a piece of steel that has like a straight cut, and in difference, the ductile fracture is like when you have a necking. When you separate or you divide a ductile material, like, I don't know, aluminum, the fracture will present a necking, like a long plastic deformation zone, and that's the principal difference between this.
The ductile brittle transition temperature is the minimum temperature in which a given material has the ability to absorb the specific amount of energy without fracture. So, when the temperature decreases, the ability to deform also decreases. So, this is tested with a Sharpe impact test, and this is particularly important in places with low temperature because the materials behave differently on lower temperatures, because with low temperatures the materials behave like a brittle material, any type of material. So there are some safety precautions to these type of temperatures.
The Sharpe impact test has many applications. Many of them determine the malleability and the ductility of materials that are being forged in the industry. When you forge a material and you want to try its malleability and ductility, you can try the impact tests. It's important to check that the testing should be in something like this. It has to be like a regimented sample. It also uses in rubbers. You can check rubbers for the shock absorption. It determines the maximum strength in metals and its alloys, and this is useful for the design. When you are designing something, you want to know what's the maximum load or the maximum impact it can take, so you test it. It's also used in quality control of many products, especially in the mechanical and aeronautical industries. It also is being used to check the difference in strengths with the different temperatures. This means that you can change the temperature in the different alloys or materials you're being tested and check how the temperature affects them.
We're gonna present the result of the experiments, and right here we have the specimens that we used in the experiment. In this side of the table we have the experiments that we use in room temperature, and the other ones when it's cold, when the ones that were inside the fridge. This side it's still 1018, and this side we have the still 1045. In these ones we can see, before all of the specimens are in the same length, the same width, and the same thickness, that it's 55 millimeters of length, 9 millimeters of width, and of thickness we have 9.5 millimeters for all of them. So first we have the ones that they were tested in room temperature, and we can see that both of them have a ductile fracture. Both of them, you can see it, and especially in this one that even they didn't have a full fracture, for example, because it's still joined with the whole specimen. And this one we can see that it had the fracture, and as you can see right here, also we are gonna put some photos in the video that it has a ductile fracture, and it's really easy to see the type of fracture that we have here. And when we tested in the cold temperatures, we have to do it really quickly because the temperature could change easily. These two materials were in minus 15 degrees Celsius inside the fridge, and as we can see right here, the type of fracture is brittle. So as a result, we can see that in a difference of temperature, especially when it's really cold or colder than these ones, we can present a brittle fracture due to the temperature, as I said. This one, it's a 1018 steel, and as we can see, it's really notorious. And in the other side, we have the 1045 steel. And also, we have the energies that were absorbed. For the room temperature, we have for the 1018 steel, the energy that absorbed was 41 pounds-feet, and the other one for 1045, it was 36.16 pounds-feet. And that's strange for us because the experiment, it's not really correct, because in theory the one that has more concentration of carbon has this one is the one that has more concentration of carbon. It's more tough. It has to absorb more energy than the other one, but in our results it's in a different way. So maybe we did the experiment in the wrong way, or we have bad results, or the calibration of the machine it's incorrect. Even we did it at first and we checked that it was correct, so we don't really know why do we have this. And also we can see that if with this temperature, at room temperature, they absorb more energy than the ones that were in cold temperature, because for this one it's more than, this one 36 and this one 36 and 41, and for these ones, the 1018, it only absorbs 26 pounds-feet, and the other one, that's 1045, it absorbs 6 pounds-feet. So we can see that when they have less temperature, we have a brittle fracture, and we need less energy to have the fracture than the other ones. Also, the influence of the carbon content of each specimen is really important when we have the experiments, because when we have higher concentration of carbon, the specimen absorbs more energy, and also it's more brittle to the temperature. So, and as we can see in the experiment, we have this kind of results. Even we think that the results are slightly wrong from the theory, and that's mainly the result or the influence of the carbon content inside the experiment of the steel. This experiment was easier than the other ones because we didn't need a lot of time and a huge machine or different machines to test the specimen, and it's really important for us because if we want to build or design new stuff or new materials, we need to make this kind of mechanical test to describe the behavior of them, and also that the brittle and ductile fractures are really important because as I said before, for the design we have to know how they behave, and this part of the course material it's really important for us if we wanna know and apply these kind of materials in the future.
In this practice, we measured the impact resistance of two types of steel, the 1045 and the 1018. We concluded that the 1045 has a bit more resistance than the 1018 because of the concentration of the carbon in it. Also, we concluded that the lower the temperature, the more brittle the material is. And we can use this in real-life applications, for example, in the making of structure.
This practice was very simple, but it's very important because, for example, when you as engineer are designing something like a vehicle, like a structure or something like that, you have to consider how the material you're going to use is going to behave in the conditions it will be exposed. So it's important this practice, like we have seen in class, the accidents and disasters that has caused when you are not considering this kind of important parameters of your materials.
For me, this lab was really interesting because we got to use the impact test machine, which was really I was curious about since the beginning of the semester because I was really eager to see the pendulum work. So to see the actual material break and the test, to me was one of the most interesting. Plus, I believe in the engineering aspect, this is one of the most useful since you test the strength and the shock absorption of the materials.
This laboratory was very important to me because of the career I am studying. So it is very important because the impact tests are made in materials that are used in the aerospace industry and the automotive industry, which are basically some of the industries that my career covers. And also it is important because the materials should resist the conditions they will be exposed.